Hey there and welcome. Ever think about something you use literally every second of your waking life? I'm talking about light. We're going to break down how it moves, how it bounces around, and most importantly, how it lets us see our entire world. Let's jump right in. So, what makes things visible? I know it sounds like a super simple question, but really, stop and think about it for a second. What's actually going on that lets you see? The screen in front of you, or the room you're sitting in. How does that even work? Okay, picture this, you're in a totally pitch black room. You can't see a thing. Then, you flip a switch and bam! The whole world just appears out of nowhere. We've all done that, right? Fumbling for the light switch? Well, that's the whole secret right there. Objects don't really make their own light, they just reflect the light that hits them. And when that reflected light hits our eyes, that's when we see. All right, so if we're going to get how we see things, we first have to understand how light itself behaves. And you know what? It all starts with something really, really basic. That's right. For the most part, light is pretty straightforward. It travels in, well, straight lines. You see proof of this all the time. Just think about a shadow. When you shine a flashlight on something, you get that nice sharp shadow behind it, right? That's because the light can't just bend around the object. This straight path is what we call a ray of light. Okay, so here's the kicker, the really important part. You don't actually see the object itself. Nope. What you're seeing is the light that bounces off of it. We call that reflection. So a light ray from a lamp zips over, hits a book, bounces off, and then travels in another straight line right into your eye, and boom, you see the book. So if we want to get a really good look at reflection in action, what's the best tool for the job? A mirror, of course. Mirrors are fantastic because their super polished surfaces reflect almost all the light that hits them. They're the perfect laboratory for this stuff, and you know what? It all boils down to just two simple, elegant laws. And these two laws, they apply to everything. Law number one, the angle the light comes in at is the exact same angle it bounces off at. Think of it like a pool ball hitting the side of the table. Law number two, the incoming ray, the bouncing ray, and an imaginary line called the normal, which is just a line sticking straight out from the surface, they all line up perfectly on the same flat surface. That's it. Those two rules run the entire show for reflection. And you see this every single day when you look at a regular flat mirror, that image of you staring back, that's just those two laws doing their thing perfectly on a flat surface. It's so predictable, so consistent that we don't even give it a second thought. So what do you see in a flat mirror? Well, the image is always upright, right? You're not upside down. It's always the same size as you. It also looks like it's just as far behind the mirror as you are standing in front of it. And of course, there's that classic switcheroo, it's laterally inverted. That's why words are always backward. Totally predictable every single time. Alright, so flat mirrors, check, we've got them. But things get way more interesting when we throw a curve into the mix. And hey, you can actually try this next bit yourself right now. So what if that reflecting surface isn't flat anymore? This is where it gets really cool. Those same two laws we just talked about, they still apply 100%, but the results, oh, they are totally different. I'm serious. If you've got one, go grab a big shiny spoon from your kitchen. It's like the perfect little science experiment because you get two types of curved mirrors in one. We're going to check out the inside scoop and the bulging outside. Okay, got it? First, look at your face in the inside of the spoon, the part that holds the soup. This is what we call a concave mirror. Now look at your reflection. What's the size like? Now slowly move the spoon away from your face. Watch what happens. Does the image change? Does it flip upside down? All right, time to flip it over. Now look at the back of the spoon, the bulging part that curves out. This is a convex mirror. How does your reflection look now? Totally different, right? Is it smaller? Does it look kind of warped? So what just happened? That inside concave surface, it creates an image that totally changes depending on how far away you are. But the outside, the convex surface, it gives you a completely different view right from the start. Usually smaller and showing more of the room behind you. Just with one spoon, you've basically seen how all curved mirrors work. Pretty cool, huh? Okay, so big picture, light seems pretty simple. It travels in straight lines, it bounces off things predictably. We've got it figured out, right? But what happens if we zoom in? I mean, way, way in down to what light actually is. Well, that's where things get really weird. And look, it would be so easy to just stop there. This whole ray of light idea works perfectly for explaining mirrors and shadows in our everyday world. But then, about 100 years ago, scientists started looking closer and they found out that light is, well, a whole lot stranger than we ever thought. And this is the part that will absolutely bake your noodle. For ages, scientists argued, is light a wave like a ripple in a pond? Because sometimes it acts exactly like that. Or is it a particle like a tiny little bullet? Because other times it acts like that too. So which one is it? Wave or particle? And the answer from modern quantum physics is neither and also both. It's this bizarre quantum thing that refuses to be put in a box. It's not a wave, it's not a particle, it's just light. So if light isn't a wave and it's not a particle, what in the world is it? And that's the big mind-blowing mystery. The simple rules of reflection we looked at today, they work perfectly for our day-to-day lives. But the true nature of light itself is one of the deepest, weirdest questions in all of science. It's a mystery that literally gets to the heart of what reality is. So I'll leave you with that. What do you think it is? Thanks for tuning in.